All right, today we're talking about exponent properties, lesson 5.2. We are not following the notes, the handout, okay? I'm having you write down your own notes so that you have them for later, okay? So we are going to talk about 5 exponent properties. The first one is product of powers. So it has the name, and it gives you a little formula here that I want you to write down, okay? Product of powers, what does product mean? Multiplication. Notice we have multiplication happening. Okay. What does power mean? Exponent. Remember yesterday we had power and root for the fractions. Power is always that exponent value. Okay. Do you agree that we have powers as an exponents? Yes. Okay. What else do you notice about these two terms? What's the same? Which is that base term, right? They have the same bases. So if we're multiplying powers of the same base or exponents that have the same base, we keep our base. And what are we doing to the exponents? We're adding them together. That's what the formula is saying. If we have powers of the same base, we keep our base and we add the exponents. Okay? Right underneath that, I want to do an example with you. Okay, so a quick example of product of powers. If I had x to the 4th times x to the 5th. Okay, what do you notice about those two terms? They have the same base, so we keep our base, which is x. What do we do with the exponents? Add them together. So this turns into 4 plus 5, which is x to the 9th. Yep. Okay. Second property that we have is quotient of powers. Quotient of powers. What does quotient mean? What operation's quotient? Division. Okay. Powers again means what? Powers means exponents. So, do you agree that right here we have a division problem? Yep, remember when we see fractions, we can think that's a division problem. Okay? What do you notice about these two terms? What's the same about them? The base is the same. Okay, so same thing. We keep our base. This time, what are we doing with the exponents? We're subtracting. Okay, so multiplication, we're adding the exponents. Division, we're subtracting the exponents. See the relationship there? Okay, so let's look at an example of quotient of powers. Let's say I had x to the 10th over x to the 4th. What do you notice about those two terms? Bases are the same, so we keep our base, which is x. Since it's division, what do we do with the exponents? Subtract. Always do top minus bottom. Okay, so it's going to be 10 minus 4, which is 6. So our new term is x to the 6th. The next one is power of a power. Again, what does power mean? Exponent, right? So do you agree this can also say exponent of an exponent? Okay. Looking at our model here, what do you notice? Okay, this time we have parentheses. What else do you notice that's different from what we had before? There's 2 exponents. What did you say? There's only one base value. Okay? There's only one base value and we have parentheses here. Whenever we see parentheses with multiplication, what do we do with the number? We distribute it, right? So, same thing we're doing here. We are going to distribute that exponent to the inside. What I want you to keep in mind, though, is that it stays as an exponent. Okay? It does not turn into a coefficient. It stays as an exponent. Let's look at an example. So, if I had x to the 3rd to the power of, let's do 2. So x to the 3rd to the power of 2. How many bases do we have? Only one. Okay, so since we only have one and we have parentheses, what are we doing to the exponents? Distributing. What's the operation with distributing? Multiplication. So distribute that power. 3 times 2 is 6. So we get x to the 6th. 2 more properties. Here's our next one. It's power of a product. Let's break this down. What's power mean? Power is an exponent. What does product mean? Multiplication. Okay. What do you notice about this formula right here, or this model? There's 2 bases. Are they the same bases? No. Okay. We have 2 different bases, both to the same exponent, because we have those parentheses. When we see parentheses, what do we normally do with the number on the outside? Distribute, right? So I'm going to take the m. What I have to be careful with is I'm going to take it to both bases. Okay? Notice that term, or that number, it's staying as an exponent. Okay? It has to stay as an exponent. So let's look at an example with this one. If I have x to the... To what? Oh, I see. If I have x, z, sure, to the 6th power. What do we notice? 2 different bases, and we're in parentheses, so what am I going to do to that exponent on the outside? Distribute, right? Is it turn into a coefficient, or does it stay as an exponent? Stays as an exponent. So, what's my answer? X to the 6th, z to the 6th. Good. Last example, last property that we're going to talk about is the negative exponent. One thing about a negative exponent is that I want you to understand we cannot have them. Okay, so if you ever see a negative exponent, you have to know that we have to switch it. Okay, so in our model here, do you agree that our exponent is negative? Yep. What did they do that made that exponent positive? They flipped it, right? So let's just jump right into an example on this one. If I had x to the negative 5. Okay. What I want us to understand right away, let's get in the habit, let's circle those negative exponents. Okay. The reason I want you to circle them is because we cannot have them. We have to switch it. Okay? What can I think of this as? What's it over? It's over 1. Okay? So if I want to make that exponent positive, I need to flip it or do the reciprocal. Kind of. So instead of x to the negative 5th over 1, our 1 is now on the top, and then the bottom is x to the positive 5. So when you move exponents from top to bottom, it changes the sign of the exponent automatically. Yep. No matter what. Yep. That's okay. And I'm going to do one more example on this one. If I had 1 over x to the negative 1. Let's not do negative 1. Let's do negative 2. What do I want you to circle right now? Negative exponent. Why do I want you to circle it? Can't have it. So to switch that, remember, we flip. So what does it turn into? X to the positive 2nd over 1. Or you can just put x squared. You don't need the over 1. Yep. So whenever you move negative exponents either to the top or the bottom, it's always going to change its sign. Okay. So these are your 5 exponent properties. Okay, so the first one we're going to start with is product of powers. A couple examples of this. Okay, so example 1. Let's do x to the 2nd times x to the 5th. Go ahead and try that one. So, product of powers, what do we notice with these? It's multiplication. What else do we notice? There's two bases. Are they the same? Yep. So we keep our base. What are we doing with the exponents? Adding them together. So this turns into 2 plus 5, which is 7. Yep. So x to the 7th power. That's your final answer.
If we don't go all the way through, do we find on?
You mean if you stop here?
Yeah.
Yes. You always want to go as far as you can. Yep. Okay. Let's look at another one. Example 2. If I have 6x to the 4th times 3x to the 5th. Okay, what do you notice about this one?
We have an actual base.
What do you mean by actual base?
Numbers.
There's numbers. Okay. Do you agree that the bases are the same?
No.
Why not?
We have different numbers.
They're different numbers. What I'm going to ask you, do these numbers have the exponent attached to them?
Yes.
Do those two numbers have an exponent to them? They don't, right? What is attached to the exponent? The x's. Okay, so what do you think we can do with these two numbers? Multiply them together. What's 6 times 3? 18. Okay, now what can we do with our x's? What do you mean by keep them? Right. We have the same bases, so we keep the same base. What do we do with the two exponents? Add them together. 4 plus 9. 4 plus 5. So we have 18x to the 9th. Yep. So if you ever have numbers out in the front or coefficients out in the front, you just multiply those together. Okay? And then the bases of the x's are going to be the same property that we had. Okay? One more example. Let's do 6x to the 9th, y to the 3rd, z to the 10th, times 9x to the 4th, y to the 2nd. All right, so looking at this one compared to number 2, what do you see? More stuff going on. Is it going to be solved any differently?
No.
No, there's just a couple more steps you have to do. What should we do first? You can kind of think combined like terms. What are you thinking right now?
6x plus 9x, or multiplying this.
Okay, let's multiply 6 times 9 first. What's 6 times 9? 54. Okay, should we look at everything all at once? No, let's take it all separately. Let's look at the x's first. Okay, what do we have?
9 and 4.
What do I do with the exponents? Add them together. 9 plus 4?
13.
13. Okay, am I done with the x's? Yep, you can start crossing things off like we have been with other things. Y. Add them. 3 plus 2? 5. Okay, what do I do with this z to the 10th? I just keep it, right? Yep, there was nothing to compare it to, so I just keep it as it is. Okay.
I did way too much.
Of powers. Let's do x to the 9th over x to the 6th. So, what do you notice about this one? Bases are the same. So whenever the bases are the same, we keep that base value. Since it's dividing right now, remember quotient means divide. Since we got a big fraction, we're dividing. What do we do with the exponents? Subtract. How? There we go. Yep. 9 minus 6, which is x to the 3rd. Yep. If you don't write this stuff, that's okay. I'm just doing it for now. Okay. You don't have to do this middle step if you don't want to. I'm just doing it so I can explain. Yep. It's okay if you go straight from here to here. Okay. Example 2. Let's do 8x to the 6th over 2x to the 5th. All right. With this, what do you notice about this one compared to number 1? What'd you say? Bases are different. What did you say? There's a number in front, okay? But do we still have similar bases? Yes, okay? What do we do with these two numbers, do you think? We're going to divide them. 8 divided by 2 is 4, okay? What do we do with our x's? Keep the same base. Where'd you get 1 from? Yep, subtract your exponent. 6 minus 5. So you get 4x to the first. Do I need to write the 1 there? Nope. Can you? Yes. Okay. Let's do one more. 2x to the 10th, y to the 4th, z to the 5th, over 6x to the 5th, y. What do you think we start with on this one? The numbers. Can I take 2 divided by 6? No, unless I get a decimal, right? What do I need to do?
I switched them.
Don't flip them. We want to reduce them. Okay, what number goes into both 2 and 6? 2, right? How many times does 2 go into 2? 1. How many times does 2 go into 6? 3. So right now I have 1/3. Do you agree? Okay. Does that make sense? How we're reducing those? Okay, we'll go over another example like this. Okay. Question?
Can I put 3 or no?
Nope, because it's 1/3 the same as 3. No. Okay. What do I do with the x's? Subtract the exponent. So 10 minus 5 is 5. What about the y? What's the exponent on this one? Yep, if there's no exponent, there's 1. So we have y to the 3rd. What do I do with z to the 5th? I just leave it on the top. Okay, so that 3 looks a little funky over there. Okay, yep, 3 is all by itself. Okay, power of power. Okay, I'm going to kind of mix these next two. So we have power of powers. And what was the one right below that? What was it? Power of product. Yep. These two kind of go hand in hand in examples. Okay, they are very similar to each other. Do you agree? Okay, so let's do a couple examples with these ones. I have x to the second times, x to the second, all to the 7th power. Let's talk about this one. We see parentheses, right? Whenever we see a number on the outside of the parentheses, what do? We usually distribute, right? But it's an exponent, so I'm going to keep it as an exponent. So I take 7 times 2. So we have x to the 14th power. Good. Let's do another one. So that was just power of a power. Okay. This one we're starting to get to products of a power. Okay. So I have 2x to the 4th to the 3rd power. You notice we have parentheses, right? Okay, so what are we going to do with this exponent on the outside? Distribute it to what? I agree with the 4. What else? We also need to do it to the number in front. Okay, because we have to do it to both terms on the inside. Okay? Yes. But I'm going to ask you this. Does this mean 2 times 3? Why not?
It's a division.
Because this is what? It's a power, right? So we're distributing it in as an exponent. So this is 2 to the 3rd power. And then what does the exponent turn into? x to the 12th. Okay, this right here is going to be our biggest issue. Okay, because a lot of you are going to want to say 2 times 3. Okay, nope, but you got to keep this as a power. Okay, a lot of you just asked, is that my answer? It is not, because can I simplify? What is 2 to the 3rd power?
8.
Remember, yep, it's 8. Remember, we learned how to use our calculators yesterday? 2 to the 8th power, and then x, not 2 to the 8th power, so sorry. 2 to the 3rd power is 8, because 2 times 2 is 4, times 2 is 8. That's how we get 8, and then x to the 12th stays. Sorry about that. All right, let's look at one more example with this one. Let's do 3x to the 1st, y to the 2nd, z to the 3rd, all to the 3rd power. Okay, since we have parentheses and an exponent on the outside, what are we doing with this exponent? Distributing it to everything. What does it go to? Goes to the 3 and all of the exponents. Okay. However, does this mean 3 times 3? No. What's it mean?
3 to the 3rd.
3 to the 3rd. What is my new x exponent? 3 times 1 is 3. What about y? 2 times 3 is 6. What about z? 3 times 3 is 9. What's the last thing I can do to this? Simplify what part? The 3 to the 3rd. So 3 to the 3rd is, it is 27. Can I do anything with these? Nope, those just stay. So I have 27, x to the 3rd, y to the 6th, z to the 9th. Okay. Last one, we're going to do 2 examples with this one. Negative exponents. We are going to get used to negative exponents and get some more practice with them tomorrow. So, negative exponents, biggest thing, can I have them?
No.
Cannot. Okay? If I have x to the negative 4th power. Remember, I want you to get in the habit. Circle that. That's an issue. Okay? What do? I heard that over there. Treat it as over 1. And now we can think we're going to flip these. Okay? So it turns into what? 1 over x to the positive 4. Yep. Another one. Remember, if we went backwards. If I had 1 over x to the negative 3rd. Even though it's in the bottom, can I have a negative exponent? No, you cannot. How do I fix it? Flip it. What does it turn into? X to the 3rd over 1. Yep, or you can just say x to the 3rd. One more I want to talk about. Okay. What if I had a variable with it? Let's say not a variable, sorry, a coefficient. If I had 2x to the negative 2nd. What happens to the 2? 2 is going to stay on the top. What happens to the x to the negative 2? Goes on the bottom as what? X squared. Yep. So the only thing that's moving is the part with the negative exponent. Okay. Quotients.